everyone, so it's good to see you all over again. I'm Natasha and welcome back. So today we're going to continue our chapter number 2, relations and functions. So today I have a question to discuss with you guys, and it's so I've already written the question. So what do we have to do in this question? So we have to find the domain and range of this thing, okay? So the function's given to us. So we have to find the domain and range of this, okay? So let's get started. Okay, so as we can see that we have to find the domain and range. So first of all, we'll be like finding out the domain of this function. So what else is that d of f, the domain of f, which is the function I'm having right now. So it's fx is equal to 1 upon root 9x squared. So first of all, one thing, as we all know, that our denominator will, is not equal to 0. So it will not be equal to 0. Okay? So which means that it's going to be greater than 0. And second thing, that we're getting that this 9 minus x squared, under root 9 minus x squared. So this is going to be a real number. So 9 minus x squared must be a real number because it's greater than 0. And yeah, that doesn't matter, because even if it would have been less than 0, but still it will be considered a real number, because real numbers include integers also. Okay, but as we all know, as far as we know, that 9 minus x squared is greater than 0. And second thing, that's going to be a real number. Okay, so what I'm going to write is this. So let's start solving it. So we'll solve it, using the really simple way. Okay, so 9 minus x squared is what is given to us in denominator. So 9 minus x squared is greater than 0. Okay, this is the thing. Now, as second thing, we know that it's saying that it's going to be greater than 0, which means that can I write it like this way? Just let me tell you. See, just have a look, like what I exactly did. And after just this way, like we're going to write this thing. It's going to be x squared minus 9 is smaller than 0. Okay, just have a look what we did. Okay, so as we know that we have studied about even function and odd function. So in the odd function, we saw that the fx is equal to the minus f of x. But in even function, we had f of x is equal to f of negative x, okay? So in this case, like we're having, so for this one, like an odd function, as we can see, and it's greater than 0. If I'm going to just remove this negative thing, which means that x squared minus 9 is, it will be less than 0. It can be less than 0, okay? This is the second thing we got from this. So it's an odd function, and by just removing its sign and writing in the x squared minus 9 is going to be smaller than 0. Okay, as it's an odd function, which means that it can be negative. So it can be negative. Okay, so now what are we going to do? So by the easiest way, so what's going to be what will be the square of 3? As we all know, the square of 3 is going to be 9, isn't it? So what I'll do here is just exactly that. X plus 3, x minus 3 is going to be will be less than 0, okay? Is it clear? So what am I saying? I'm saying that x plus 3 and x minus 3. So as we don't know that it can be like, in the first condition we had that it's going to be greater than 0. But in the second condition, as we can see, it's an odd function, so it can get in negative value. So what I did was the addition and subtraction of here, and write it like the same way. It's less than 0. Okay, that's what I did. So through this way, I can see like there are two values coming from me, is positive 3 and negative 3, as I can see. So what I will write is negative 3 is smaller than x, and x is smaller than 3. Okay? Just have a look. Negative 3, as we're getting two values, negative 3 and positive 3. That's it. So negative 3 is going to be, it will be smaller than x, and x will be smaller than 3. What does this mean? So this is what this will be our domain. That was really easy. So, to find the domain, it was definitely really easy to find the domain, okay? So, through this way, like, first of all, we have to know that is the denominator going to be, well, of course it's going to be greater than 0, because it's not going to be, because it is not equal to 0. No denominator, so, so nothing is equal to 0 in the denominator that's given. So it's going to be greater than 0 in the odd function, even function, and about getting the two values, and this is what, this is through this way, like, we're going to find the domain. So it's negative 3 less than x, and x is less than 3, which means that these two numbers are not included. So I'm going to use an open, to understand it clearly, open interval, okay? Okay, so it's going to be negative 3, comma 3. Okay, just have a look, these two values, okay, and these two will not be included. Got it? So what I will write is, let me just write the domain also. Like, this is going to be the domain. Okay, so the domain of this f, the function we're having, is going to be negative 3, comma 3. Okay? Okay? Yeah. So, so it's saying that negative 3 is going to be less than x. Isn't it? Negative 3 is going to be less than x, which means that x will be greater than negative 2. So this means that it will have the value negative 2. And it's saying that x is smaller than 3, which means that 3 is larger than x, so which means that it's going to be, it's going to be 2. So this is what I'll say, okay? That's it. So we found out the domain, and now we're going to find the range. Domain's done, now we're going to find the range. Got it? So to find the range, it's obviously easy. So first of all, the domain is going to be the x. But now for the range, we're going to use y, as we know that x is going to be our input value and y is going to be our output value. Got it? So we're going to use y in this place to easily find the, range. Okay? So I'm going to say that let y is equal to 1 upon under root 9 minus x squared. Okay, just have a look. Let's say that let y is equal to 1 upon under root 9 minus x squared. Got it? So one thing that we know that y is not equal to 0 and y will be greater than 0, as we can see from this thing. Okay? So what I can say is that if we're having a particular value for x squared, so which means that whatever the value of x squared is going to be, the value of y squared will be exactly same to x squared, okay? So let's see what's going to be the value of x squared. Okay, so for the value of x squared, so if I'm going to just, write it like this way, y squared is equal to 1 upon 9 minus x squared. What I did, I just removed that root, the square root, and just, shoved it on the, and just moved it to the left hand side, so which I got y squared is equal to 1 upon 9 minus x squared. So which means that x squared will be also will be also, what is it going to be? It will be also, related to it. But that's like, as we all know that if x and y, if we're talking about constant function, which we have just discussed, it's not been a long time. So actually we discussed about constant function relations and functions, like when we're discussing about some functions and their graphs. So let's just forget about everything. Let's just focus on constant function. So in the constant function, what we just studied about it is if the value of whatever the value of x is going to be, y will be exactly constant, which means that if I'm going to say that y is equal to 3, then which means that it doesn't matter to the input value, okay? Whatever, if the output value is given to us and it's 3, let's say it's 3, then it's going to be 3 no matter what the input value is. But according to the identity function, as we know that it's going to reward us the same value. So which means if we have the value, if in the input we have in the x, we have value -1, then y is also going to be -1. And if x is 0, then y is also going to be 0. Then so which means in identity function, like both values will be same. But in constant function, like whatever the y is, it will stay constant. It will be on the same value. Okay, it will have the same value. Even if the x value, even if the input value is different. Okay, that doesn't mean. Okay. So, so to not get confused, what I'm going to do is let's just forget about x squared. So I just wanted to solve it in a really easy way. So, I think that we should forget about these functions and the graph thing. So let's just solve it, in a really easy way. So one thing that I've just seen right now is y squared is equal to 1 upon 9 minus x squared. One thing I want to tell you is the square root of a real number is always non-negative. I'm also going to write this. Where should I write? Okay, I'm going to write this here. Square root of a real number is always non-negative. Okay, so which means that the square root of a real number is always going to be positive, non-negative, which just exactly trying to tell us that it's going to be positive. Okay, it's not going to be negative, it's going to be positive, and that's it. So, if I'm going to shift this x squared at this place of y squared, and the y squared at the place of x squared, is it going to be wrong? No, it's of course not going to be wrong. As we're just going to look for the value of x squared. Got it? Okay, so what I'll do is, I'll just do it like this way. So as I'll shift this, x squared is equal to 1 upon 9 minus y squared. Okay? Okay, just have a look. Cool, right? Okay, so I want to tell you something, that if the 9 was related to, let me just tell you again, okay, so that you're not getting confused. So what I did, that I shifted this x squared on the place of y squared. So this means the 9 which we have right here is not going to stay on the exact place. So it's going to be 9 minus 1 upon y squared. Got it? As you just shifted it like here, and the x squared here, and the y squared just after, 1 upon y squared. That's it. Okay? And as we know that x squared, x is going to be greater or equal to 0. It's going to be greater or equal to 0. Got it? greater or equal to 0. So just have a look. X squared is going to be greater or equal to 0. And yeah, for all the elements x that belongs to the domain of function. So domain of f is, what is it? It's negative 2 to positive 2, okay? So this x squared is going to be greater or equal to 0 for all x belongs to the domain of f, so dff, so df. Got it? Okay, this thing's clear. Now, as we can see that x is, x squared is greater or equal to 0, which means that the value of x is going to be like, either it's going to be equal to 0 or it's going to be greater than 0. That's one thing that we have got, okay? So what are we waiting for? So let's just find out the range, because we have just solved everything. So now, like, this thing has become really easy for us. So it's crispy clear, okay? It's going to be crispy clear to us. So now it's just like this way. So we'll be like, able to solve it really easily. Got it? So which means that this is x squared. So I can also write this thing in the place of x squared. So which is going to be 9 minus 1 upon y squared is greater or equal to 0. Isn't it? Because x squared's value is this actually. So I can also write 9 minus 1 upon y squared at the place of x squared. Isn't it? It's of course right. Okay? So after this, one more thing that I'm going to write this, but y squared is greater or equal to 0. Okay. Okay. So, like, as we have studied about it, then if the function of the denominator we have, it's never going to be, it will never be equal to 0. But in this condition, it's kind of different. So what I'll say that y squared will be greater or equal to 0. So this is absolutely right, okay? In this case, like, we're not talking about anything, it's just a different thing, okay? So it's not related to that thing, okay? Okay. So as we know that we have just found out everything, and now what I'm going to write is going to be really clear to you. So let me write it just right here, okay? Okay. So what I'm going to write is y squared 9 minus 1. Like what? Oh, let me write it again. Okay, 9y squared minus 1 is greater or equal to 0. Okay, 9y squared minus 1 is greater or equal to 0. So what I'll say is that y squared. So what is going to be the value of y squared? By just looking at this thing, what's going to be the value of y squared? Like, can we just guess it? Can we just guess what is going to be the value? So it's going to be really easy. So what I'm going to do is just going to shift their places. So y squared minus 1 upon 9. That's it. Nothing. So actually we're going to find a value of y squared after, when we'll get done with these things, okay? So we haven't found out the value of y squared. So, but yeah, for the relation of y squared from 1 and 9, I'm going to say this. So y squared minus 1 upon 9 will be greater or equal to 0. Okay? Is it right? Is it, right? Yeah, it's absolutely right. So let's move on. Now everything has been, clear, and so what now is nothing. Now everything has become just really clear. So, as according to this thing, what we did here is relates to 9. I'm gonna just do the same thing right here. Okay. So y plus 1 upon 3 and y minus 1 upon 3 is greater or equal to 0. See, what I did is as I just asked you what is going to be the square root of 9? As we know, it's going to be 3, and the square of 3 is going to be 9. So what I did, and those were y squared, so I just used them. So, and in this condition, same also what I did. So, but in this condition, like it was saying that it's going to be less than 0. But in this condition, we have that this thing is going to be greater or equal to 0. Okay, just get this thing. Okay, it's going to be greater or equal to 0. Okay, so 2 possible values I'm getting right here. Is this the negative 1 upon 3 and the positive 1 upon 3? Can I get these 2 values? Will I get these 2 exact values? Can you just tell me? Will I get these 2 values? Of course I'm going to get. So what I'll say is y is going to be, y is going to be less than or equal to negative 1 upon 3. It's going to be less than or equal to 1 upon 3. Or I'll say that y is going to be greater or equal to negative 1 upon 3. So this is kind of really confusing. So what overall I'm saying that we can see this sign greater or equal. So greater or equal, which means that we're talking about a closed interval. So so by seeing this thing, it's really easy. So we've got one thing. So we find out the range R of f. It is going to be 1 upon 3, infinity. Just have a look. Is it going to be this thing? Is it going to be this thing? Okay, so as I told you that y is going to be smaller or less than negative 1 upon 3, or y is going to be greater than or equal to 1 upon 3. But y is greater than 0, so which means that the value will be positive, okay? One thing that we're going to get, that it's going to be positive. So, as we know that y is going to be greater than or equal to 1 upon 3. So, y is going to be greater than or equal to 1 upon 3. So, which means the range of this function is going to be 1 upon 3, infinity. Infinity, which means, and one more thing, that for the infinity, we never use this closed interval, because infinity is it's going to be going, it will never end. So, it's always open. So, we can't just close it. Okay, it's always going to be open. We can't close it. Got it? So this is a really easy thing. So whenever we get the infinity thing, we're always going to be, put this open interval. So as you can see that we find out the domain plus the range. Both the things. Wasn't it easy? So what was just what it was saying is that simply one thing that was there is that y is going to be greater than 0. Second thing, y is going to be less than or equal to 1 upon 3, or it's going to be y is going to be greater than or equal to positive 1 upon 3, okay? Positive 1 upon 3. So y is going to be greater than or equal to positive 1 upon 3, and or it's going to be, or y is going to be less than or equal to negative 1 upon 3. But the third thing, it is sure that y is going to be greater than 0, okay? It's going to be greater than 0. So that was, really kind of fun, I think. Yeah, it was kind of a little bit confusing, but we saw that in a really easy way. Okay, so I think that this question was I think that this question will be helpful for us to understand about the functions, like how can you find the domain and range of the function, because I think I haven't taken any questions, so I haven't taken any question related to this, so like I've never discussed this type of question with you. So I thought of, just having a discussion of this question. So we find out the domain and range, so it was really easy way. So one thing while remembering that the domain, what am I saying? It's gonna be denominator, okay? I don't know what did I say, just, okay, whatever. So the denominator is gonna be greater than 0, okay? Simple. What, if I'm not exactly sure about this thing, if it's gonna be greater than 0, but one thing that it's never gonna be, so it's like 9 minus x squared, according to this question, 9 minus x squared is not equal to 0. So one thing that we got, if it's not equal to 0, which means that it is a real number. So it's gonna be greater than 0. One thing that we got just right now, and then later on we just shifted it. So like this way, okay. So what I did was related to the odd function and to the less than 0 and all these things. And for the range also, range was of course related to y, and domain was related to x. So we didn't have to write anything else or to think extra more about it. And when we were finding the domain, but in the range, like we had to discuss or think something extra related to it. But that was really easy. So this type of question is really easy. So in which like most of these questions will not have any confusions. If this question is clear to us, then every question will be clear to us. So as I've said, that is all for today, and in the next video, we'll be doing a new chapter maybe, I think. And the next chapter, which I'm going to discuss with you, is going to be, principle of mathematical induction. So mathematical induction, we'll be discussing about this topic in another video, or maybe in next video, okay? So, or if I'll be not discussing this, the mathematical induction topic with you guys, then for sure that I'll discuss some questions related to this chapter. Maybe then, maybe later then, we'll discuss about the chapter. So whatever. So thanks for watching and have a great day.